So hello, everyone. It's a pleasure to be here. Today, I'm going to present our research paper of towards summarizing case decisions via extracting argument issues, reasons, and conclusions. So I'm starting off the motivation of our project. Why summarizing a case decision is so important. The legal summaries are a necessary tool for legal practitioners to analyze a huge amount of legal material. Unfortunately, not all the decisions have the high quality summaries. The reason for that is simply because it's too costly to do that. So automatic legal summarization could help legal professionals and the public to access legal information with much lower cost. So in our study, we try to use our argument mining to improve the legal case summaries by picking up those sentences that comprise important issues, reasons, and conclusions. And we hired law school students to annotate those key information in expert prepared case summaries and full case decisions. There are two main contributions of our project. First, we employed an IRC type system for generating the succinct summaries. And second, we experimented an intermediate structure of mapping from a mapping of the key information IRCs from the summaries to the full texts. So what is a legal argument triplet? We segment a legal argument into three elements: issue, reason, and conclusions. We refer to this key information as legal argument triples, RC triple for short. So presumably those expert prepared summaries will have those key information. The benefits of using the IRC triple would help to clarify the case decisions and make it more accessible and transparent to its audience. Besides, it's an example of combining legal domain knowledge with argumentation that could supplement the machine learning techniques. This is an example of summarizing case decision using legal argument triples. So in order to get a high quality annotations, we hired law school students to do annotation or followed a detailed annotation manual for us. The annotators would do the annotation individually, and then we would resolve any differences between the annotations through the Zoom meetings with consensus of both annotators. This is a screenshot of the annotation tool we utilize for the study. Annotators would simply use cursor to mark the sentences according to the annotation manual. We also ask our annotators to do annotation for the full text. Instead of asking them to read through the whole legal case decision, they would pick up the keywords from the annotated summary sentences as pointers, and then use them to locate corresponding sentences in the full text. Then we resolve any differences between the full text annotations as the same manner as for the summaries. The benefits of using this strategy is to help us to gather a sizable data set in a short period of time. And also, it is the first step of projecting the annotations from the summaries to the full text automatically. Cohen-Kappa coefficient is used to measure the degree of agreement between the two annotators. The mean of the coefficients across the all types in the full text is 0.827. Given our experience and the task, it indicates a reasonable agreement about the nature, the type of the sentence types. So our annotated data set is based on the paired cases and summaries we received from the Canadian Legal Information Institute. The uniqueness of this corpus is all the summaries are prepared by the legal experts. Those cases have very rich legal information since they cover different kinds of legal claims and issues. In the current phase, we have already annotated 574 summaries and corresponding full texts. This figure shows the distribution of annotated IRC type of sentences in both summaries and the full text. As you can see, the non-IRC type of sentences are the majority in our annotated data set, which make our data set imbalanced. However, the manually mapping from the annotated summaries to the full text is still a very time-consuming task. So we decided to experiment automatic mapping from the annotated summaries to the full text, which is intended to decrease the annotation cost and improve the annotation efficiency. The strategy we use here is utilizing sentence border embedding, which would help us to derive semantically meaningful sentence embedding with fixed size. Then we use the sentence border embedding to calculate similarity scores for the annotated summary sentences with full text sentences, and then only keep the top 5 sentences with highest similarity scores for the further use. The novelty here is we're trying to generate weak labels by deploying the state-of-art sentence border embedding. Those are examples of automatically mapped IRC, the issue, reason, conclusion sentences. As you can see, the top ranked sentences often include the same keywords as the manually mapped sentences. We also find the reason sentences have fewer overlapping keywords than the other types. For the study, we choose different kinds of deep learning models to experiment, like the LSTM, synonym BERT, and synonym BERT models. Since our data set is imbalanced, we're trying to remedy the imbalance issue of our data set by using different kinds of loss function. There are 3 kinds of loss function we use here: the cross entropy, focal loss function, and the F1 loss function. For comparison purposes, we train our models on manually mapped data and automatically mapped data separately, and the F1 score is used to measure the performance of our models. This table shows the results of our experiments. As you can see, after training on the manually mapped data, the LSTM has the better performance on identifying the issue and the conclusion, and the synonym have the better performance on identifying reasons. After training on the automatically mapped data, the LSTM has the better performance on reasons, and the synonym BERT has the best performance on identifying conclusions. What we can learn from the results of our experiments? In general, the model performed much better after training on the manually mapped data than the training on the automatically mapped data. And we also noticed that the different models have their own strengths of identifying different types of sentences. For example, the LSTM has better performance on identifying issues and conclusions, and the synonym has the better performance on identifying reasons. We also noticed that the precision score decreased after training on the automatically mapped data. Our intuition about the decreased precision has something to do with the quality of the automatically mapped data. For conclusion, we confirmed that the deep learning model performed pretty well on extracting the IRC triples from the full text. And the loss function could mitigate the imbalance issue of our data set to some extent. The results of the automatic mapping shows the possibility for the automatic annotation in the full text. For the future work, we will continue to increase the size of the annotated data set, since the data size is not large enough for final comparisons in terms of the model performance. We also will explore more effective methods to identify the issues, reasons, and the conclusions. Finally, we would like to explore the possibility of generating the summaries by employing the automatic annotation. Last but not least, I would thank the National Science Foundation for supporting our work, and the Center for Research Computing for providing the computing resources, and our partnership with University of Montreal Civil Justice Lab and the Canadian Legal Information Institute for providing such a unique corpus for our study. Okay, thank you. So any questions?
Thank you very much, Ms. Chu. Now we are going to the questions and answers section, and we have some questions here. First, based on your investigations, what is the perspective to have better results from automated annotations?
So the first of all, I still will increase the size of the annotated data set. As I mentioned before, in the presentations, is our data set only comprised of 574 the annotated cases. So it's not, especially for the deep learning model, it's not large enough to give a very uh, promising results. So the first thing we will do would be increasing the size of the data set.
Okay. And the second question is, when searching for annotation tool, uh, which one did you choose and why have you chosen it? And
Oh,
which
okay.
limitations has the annotation tool?
Oh, the annotation tool. I have to thank for the second author, Yarmir. That actually he is also of our annotation tool. It's a personalized or designed for our specific task. This is the annotation tool we designed by ourselves. So it's not something you could search online. So generally, we have very nice experience of using this tool. And very nice. And you can see the screenshot I presented before. The layout of the annotation tool is very simple. The text column in the middle would be the annotators to annotate all the sentences for us. And there's a little menu would pop up if they select the sentences with three options. They would simply choose one of the options. And the sentences will mark the different colors according to the different types of sentences. Very easy to use.